Welcome back. In this series of lectures, we're going to talk about blurring and smoothing images. A common operation for image processing is blurring or smoothing an image, and smoothing an image can help get rid of noise, or help a computer vision application focus on general details. Keep in mind there are many methods of blurring and smoothing, and we're going to go over quite a few of them. Now, often blurring and smoothing is combined with edge detection. Edge detection algorithms detect too many edges when shown a high-resolution image without any blurring. And since we're going to be learning about edge detection later on in a future section of the course, we might as well understand blurring and smoothing at this point. So just to show you a quick example of why blurring or smoothing an image is useful, let's imagine that we have an original image of a dog. So all the way on the left we have a dog's face, and if we try just to detect the edges in that particular image without any blurring, we would get the middle figure. And you can see here that it's too noisy of an image, it has too much detail, so we're detecting far too many noises. And if we want to detect just general edges and shapes, what we can do is we can blur the image first and try to smooth it out, and then apply a edge detection algorithm on it. And then you'll see what we have all the way on the right, where we can clearly start to see the edges of the distinct dog's face. So we're going to be exploring quite a few methods. One method we'll be exploring is called gamma correction, and gamma correction is actually not so much a smoothing or blurring, but instead it can be applied to an image to make it appear brighter or darker depending on the gamma value chosen. So over there on the right hand side I have an image, and right in the middle we have gamma is equal to 1, or the original image, and that's the second from the top, and then we can apply a gamma correction to make the image appear brighter or darker. And if you've ever kind of messed around with any sort of photo app software where you can make an image brighter or make an image darker, that is gamma correction in action. So we're going to actually show you how you can do gamma correction with OpenCV. Then after that, we're going to be exploring kernel-based filters. Kernels can be applied over an image to produce a variety of effects, and the best way to explain really how a kernel works is through an interactive visualization. I'm actually going to go and open my browser to satosa.io/ev/image-kernels, and that's going to help us understand what we actually mean when we're talking about kernel-based filters, because a lot of smoothing and blurring operations actually depend on what's known as a kernel operation. Let's go ahead and go to this link and then explain further. Okay, here we are at the link on image kernels, and this link is a really nice visualization of how kernels actually work. And an image kernel is essentially just a small matrix used to apply effects. And those effects can be anything really, depending on the kernel, and the ones we're going to look at in this particular series of lectures are the smoothing and blurring effects. We can see here that we have an image of a person's face, and here we have all the way on the right the tiny little original image, and then we kind of blew it up so we can see each of the pixels and their particular values. So notice all the values should be somewhere between 0 and 255 because it is a grayscale image. So right now we're just inspecting a black and white image, and if you're at this link, you can begin to kind of hover over and see how each particular value, as you kind of hover over it, you get to see the value on the left-hand side of the actual lightness or darkness, and then it highlights the corresponding image or pixel in the image on the right-hand side. Now, what we're going to do is apply a kernel, and there's different kernels that you can apply, and a kernel is essentially just a matrix, and you can see here that there's different types of kernels. So we're going to actually choose the blur kernel. In this case, the blur kernel is going to allow us to blur the image above. So the way this works is we take a 3x3 block of pixels on the image on the left-hand side, and we're going to multiply each pixel by the corresponding entry of the kernel, and then take the sum. That sum then becomes the new pixel on the image on the right. So let's actually go through this process. We're going to start over here towards the actual top left of the image. So notice here how right now on the original input image, I'm scanning a kernel, and this kernel is a 3x3 kernel where the values are, if we scroll back up, these particular values right here. And this is known as a blur kernel because after lots of studies, they've seen that this can actually blur an image effectively. And there's, as I mentioned, many different types of kernels, ones that sharpen, one that do outlines, etc. But since we're focused on blurring and smoothing, we're just going to look at this blur kernel first. So we have this kernel, and what we end up doing is we take, as we scan the image, we take those 9 values of the 3x3 grid of pixels in the original image, and then we're going to multiply it by each corresponding value in the kernel. So here you can see that if I'm looking at that corner, then that's 206 times that 0.0625 of the blur kernel plus the other multiplication of 205 times 0.125, and so on. So you end up adding all those images, and then you end up getting an output, so 178. And that becomes the new corner image of the output. So notice here, when we apply the blur, we can actually see, even though we're quite zoomed in on this image, that it does appear to have blurred the image. Now, something to note is that as you are scanning with a 3x3, if you start looking towards the edge of an image, you're actually not going to have enough pixels. So something you can do is just end up having the output image with a border. And there's different ways of dealing with actual borders of images when it comes to kernels, and we're going to discuss that in more detail, specifically when we talk about convolutional neural networks that heavily depend on this sort of kernel function in order to apply changes to an image and learn larger and larger features. But for right now, the main idea I want you to understand is we can take an image of values, just like we have here. So we have all these images. This one happens to be grayscale. And then we can apply a kernel to it. And all the kernel does is it takes the shape of the pixels of the kernel. So right here we have a 3x3 kernel. So we take 3x3 pixels, and then we multiply it by the kernel values, and then we sum them up, and that's our new output value. So we can see as you move along what the new output values are. And this is a great way to visualize this. And I encourage you to come to this website and then check out other ones. So these Sobel ones, we're actually going to be checking these out as well. So you can see here how it ends up detecting certain edges on the left or on the right. Okay, so in the next lecture, we're actually going to explore these further with OpenCV. I'll see you there.